Okay, so like I said, as far as the practice goes, I'm gonna keep checking it every time there's downtime, and I'll put in the score. Again, you can turn in late stuff for full credit up until the unit test. The unit 1 practices are already disabled. The only thing I don't ever disable submissions to are the study guides, because those are a lot of points, plus some of you might want to come do test correction still. And you have a final at the end of the semester, like all of those things are still helpful. But those 10-point homeworks as we go through the unit are more checkpoints for you to see how you're doing before the unit test. After that, it's kind of meaningless to do them. They don't have a huge effect on your grade, other than, of course, like how you do on assessments. Really, your practice helps you do better on assessments. I already talked about the statistics from the Unit 1 test, so I'm not going to talk about them again. Overall, it went really great. I think most of your grades leveled out to something that you like, at least passing for most of you. If it's not a grade that you like right now, then the next step would be come in during office hours and do test correction for half credit back. I can help you if you ask me, but otherwise, like, you're just kind of looking at the test you most recently took and correcting it, showing where, having an explanation, and then you'll get half credit back, which for a 100-point test, like, that's a lot that you can get back. The constructed response, I'm going to take my time grading. The first time around, I graded them pretty fast so that you can see them. Now I have like a bunch of other things to get caught up on, and then I'll grade them and put them in. So either your grade will get better or it'll stay the same. So always keep the higher of the two scores. But you'll know that it's your new grade when you see that comment that says retake given during class time, higher of 2 scores. So yeah, that is that. We're moving on. The statistics unit, I mean, we'll revisit statistics again in unit 3, but now I feel like we're actually getting into the algebra of things, like actually solving for variables, things like that. So some of it's review, some of it's things that you struggled with for years. I'm really trying to set you up with a good foundation for the rest of the math classes. So if you've not like bought into that idea yet, the sooner that you do, the sooner that you start trying, when I give you time to try, I think the better off you'll be for the rest of your math classes. But today we're doing the second lesson, which is looking at how equations can help us describe relationships and constraints. The word constraint, what's another word for constraint? Doesn't have to be like a math word. But like, what are constraints? Or another word for it. You're in constraints, what does that mean? Yeah?
Something like held back.
Okay, being held back. In math, it's kind of similar. It's things that hold the situation back, things that are limiting in that situation. So we're going to look at situations and you're going to make equations for them. And I'm going to give you some ways to do that by looking at what's limiting, looking at what's staying the same, things like that. So pay attention to that when we get to it in the lesson. By the end of the lesson, you need to be able to tell me which quantities in a situation can vary and which ones cannot. And be able to use letters and numbers to write equations representing the relationships in a situation. I'm recording right now. I record all the time. I usually will have the lesson from last year in case you ever need to work ahead. Maybe you know like something's going to come up and you're not going to be here. It's always in the slides. I didn't take a picture of the assignment, but it's in there, I promise. All the assignments are in there actually for the week. So feel free to work ahead. You might already know how to do a lot of the stuff, but you revisit it every day. So you'll have an assignment with every single lesson you can start with. And you should expect your first quiz for this unit to be this Friday. Again, quizzes are hopefully not very stressful. Hopefully that they're just checkpoints for you. Now that we have that 150-point assessment in the grade book, quizzes don't do a whole lot for your grade. Okay, it's really just so you can check along the way how you're doing prior to that test. So please, the day after you take it, I usually make it doable, do corrections on your own time, and then move on from that. Now, if you want to, I guess, improve your grade, it's really those test corrections that you need to do. Speaking of that, and I did message it out in Parent Square, so if you're not on Parent Square or your parents are not, I'm sure that you do. I can't like mass email anyone, I'm not allowed to do that anymore. So you need to be checking Parent Square, download it on your phone, it's like a really easy app to use. But I let everyone know that I'm not available for office hours this Friday. Normally I have it Fridays, you can see on the whiteboard. But I will be available tomorrow after school should you want to come by. And that is better anyway, because first athlete grade check is this Friday. You would need to have everything turned in by Thursday if you wanted to affect your grade by Friday. Like if you were to come to office hours on Friday, like it probably won't be entered that same day. So just tomorrow's an unusual day that I'm available, but I am available if you want. Okay, so now on to the lesson. We are gonna start with a math talk. We did them once before, but I'll re-explain them. You are trying to do this without a calculator and without scratch work. Try to come up with an easy way, I guess, to evaluate this in your head. And once I see enough thumbs, like you put your thumb up when you know it, then I will call on a few people to share like the many different ways you could have thought about it. So first is 25% of 200. Without a calculator, without scratch work, be able to tell me what that is. Put your thumb up when you think you know what 25% of 200 is. Jordan, what'd you get? All right, anyone get something other than 50? Okay, so then Jordan, how'd you get 50 without using calculator, without scratch work? And how does that help?
When you just, we're going up to, it should be, 107.
Okay, so split the 100 in half. And that gives you 50, which is the 25% of 200. So I'm gonna ask a few other people to explain how they got it. Hopefully there's some differences out there, because I doubt all of you thought of it this exact same way. Did you? Okay, so I need like a variety of answers. We'll kind of latch on to ways that work for every situation and ways that might just work for this unique one. So who else had their thumb up that thought of it differently? Tristan?
We could turn 25% into a decimal or like so. Yeah, that, and then you multiply it into 200.
So when you multiplied it, did you do this in your head? Like that? Okay, and that's something you can do to easily get the percentage of something, like what it actually the value is. This is what I'd probably do if I had a calculator. Otherwise, like you were supposed to do this in your head, but this is possible to do in your head. And if you did, it would look something like this. Did I do it right? 0, 0, 10. 0.004. And then. Why am I like, what am I doing wrong? Oh, yeah, that's right. I'm like, there's something. Okay, so hold please. I don't usually do math this way, so that's why I was like, it's not working this hour. So we had to put a 0 here as a placeholder, and then times that is 0, times this is 0. Now it's making sense when I add it. And then we have the 2 decimal spots to account for. So yes, it is 50. That's one way. Anyone do it another way that they think might be easier? An easier way to think of it than our 2 classmates already. All right, then we'll move on to the next one. So the next one I'm gonna ask you to do without a calculator, without scratch work, is 12% of 200. When you think you know what 12% of 200 is, then put your thumb up. So if you be actively trying to find it, not having like side conversations, it's only on the screen, it's not anything you have to write down. We're just trying to get you to see maybe a pattern. Macy, what'd you get? 24. Anyone get something other than 24? All right, and Macy, how'd you get that?
12% of 100 is 12.
Okay, so 12% of 100 is 12 multiplied by 2, there's 200. And that is the correct answer. That's the way I thought of it for the first one. 25% of 100 is 25. And then just times it by 2, because we're talking about 200. So percent by definition is like per 100. We never do out of 105% or anything like that. It's out of 100% always. So per 100, and since we have 200, all we have to do is times it by 2. Did anyone get it a different way than what we've seen so far? Okay, so try to adapt some of the ways that your classmates talked about it. I should see more thumbs up. Don't just give up. That's where you're just like not setting yourself up for the rest of high school to do well. You need to participate. So 8% of 200. When you think you know it, put your thumb up. If you're listening before, then it should be easier. To be looking at the screen. Only on the screen. All right, Cadence, what did you get? Anyone get something other than 16? Okay, I did see more thumbs up, so thank you those that participated. And Cadence, how'd you get 16? Okay, so this method, one that we've seen before, one that the rest of you could have easily implemented to help you get the right answer in your head without a calculator. Cause yeah, this is an easy fraction to predict. This is easy numbers to figure out. but 12% and 8% might not be. So that's where we're finding that this method of thinking about it seems to work the best. Now, the last one, when you think you know it, put your thumb up. P% of 200. And closing. So you might not get like a number, you shouldn't get just a number, it should be more of an expression. Think of what we did in the first three situations. And give me an expression for how to find P% of 200. Thumb up when you think you know. Know it. Hey, Ella, would you get? Okay, anyone get something other than E times 2? Or think that this is wrong? Now that we see it, do we think it's right? Does it make sense? So see what happened in the first three situations. When we thought about it as whatever percent of 100, because that's what changed each time, the percent we were finding out of 100. It really just ended up dropping the percent sign, right? So we have a P that no longer has a percent sign. And then what did we do both times? So if I just do the same thing, no matter what P is a variable right now, it's varied. But no matter what percent of 200 I ask you to find, all you have to do is get rid of the percent sign and times it by 2, right? What's 3% of 200? 3% of 200. What's 10% of 200? 31% of 200. Like, that's the same pattern, right? It works no matter what P is. So this is the right answer. Good job. If you want to write it another way, like maybe you want to put, I don't know, not a multiplication sign, maybe you just want to smush them together, like how that implies multiplication. You could show it like that. Normally, we wouldn't put like P2. It'd be 2P or P times 2. We put the actual sign there. Questions on that? Now, pay very close attention, like make eye contact with me. That's what we're gonna try to get you to do in the next activity. We want you to see what is staying the same in each situation and what is varying. That will help you make your equations, even when, I don't know, maybe you struggle with equations your whole life. Maybe word problems are hard for you. Maybe you don't like to read. I don't know. But that's gonna help you make your equation. Looking at what constraint, what's a constraint, what's limiting, and what can vary. And that's one of the learning targets, figuring out what can vary and what cannot. So this activity that's next, the one that's actually on your paper, you are going to, and you have other people to work with in your group, so like you're not completely on your own. You should all be giving it your best attempts. But you will be making equations for each of these situations on your paper. What do equations have to have? Not necessarily, I don't know what you mean by answers. What do equations have to have? Picking on you because I feel like you're not paying attention when you're not listening. So class, what do equations have to have? It's almost in the word. An equal sign. So make sure whenever you're giving me an answer for these, I need to have an equal sign. I don't necessarily need you to tell me what the variable equals, like. In some of them, you might not be able to actually solve it like we did on Friday. You're just making an equation to represent the situation. You have about 2 or 3 other people that can help you at your team, so I shouldn't see like papers, or I shouldn't have people that I call on that just aren't like. Okay. One of my coworkers who also teaches Algebra 1-2, we're not allowed to say, I don't know in his class. You say, I don't know 3 times, we take a test. So you have to come up with something. I don't even care if it's wrong. Sometimes I like the wrong answers because then they lead us to like. Yes, and also what other people might be confused on too. So give it your best attempt. Needs to have an equal sign and needs to represent the situation. You have 6 different situations, a lot of them repeat. So I'm gonna give you 5 minutes to figure it out with your groups. I think that's fair. Okay, so the 5 minutes are up. Right now, the reporter for your table will be whoever is sitting closest to the door. That's why when I give you 5 minutes, you actively work, you ask your table if they agree. Otherwise, you're just on the spot for whenever it's your turn to be called on. I also didn't hide what I wanted from you. I just want equations that represent each situation. So we'll start with table 4.
Oh, wait, that was. Alright.
So hold on, I'm waiting for people to stop talking. Because collaborative time is over now. That's why you should use it when I give it to you. All right, but table 4 for situation 1A, let me read it first. Blueberries are $4.99 a pound. Diego buys the pounds of blueberries and pays $14.95. What equation to represent that?
The equation we said was $4.99 times B equals 14.
Okay, class, does that seem like a solid answer? Okay, I have some head shakes. No, do we have any different answers that we'd like to share? What do we got?
Oh.
Okay, any other ones out there that we got? Okay, so let's see. There can be more than one way to write something and it still be true. And then of course there's wrong ways to try to write the same thing, which we will evaluate both. So if it works, it should tell me like whatever I plug in for B should make it true. You didn't actually have to solve it. We just wanted the equation that represents it. But does it make sense that we should just multiply however many pounds we're buying by the price? Would that give me the total I paid? What if I just bought 1 pound? How much would it cost? $4.99 because it's $4.99 a pound. Did this person buy 1 pound? No, because they spent more than $4.99, right? Like they spent, or they bought probably about 3 pounds, but not 3 pounds exactly. So use your critical thinking skills, make sure it makes sense. I will acknowledge this is the one that I would probably think of. And then I'll evaluate if this one's still right too. But whenever you are making an equation, highly recommend identify any totals, meaning like total cost, $14.95. Any totals are usually alone on one side of the equal sign. I think that makes it easier to think about what contributed to that total, which would be the cost per pound. Whenever it says something like per pound, per person, each day, every week, things like that, you should be thinking of multiplication. Because that would make sense. Like if I wanted to buy each of you 2 cookies, and I don't know, there's 30 of you, how many cookies do I need to buy? So like you're multiplying to figure that out. So whatever pounds he buys would have to be multiplied by the price to give me the total cost. Right? Everyone with me? Earlier, someone said $4.99 plus B, which wouldn't make sense, right? Because if B is supposed to be pounds and they buy 1 pound, it should be $4.99, not $5.99, right? So like plug things in and see if it makes logical sense. So then, does this one also make sense? Is it an equation? Yeah, it has an equal sign. Would it give me the value of B if I solved it? Yeah. So there's inverse operations, right? Like what's the opposite of multiplying? So it looks like if I were to actually solve B, if I divided $4.99 on each side, it would give me this. So this also works too. I feel like my mind only goes to this one because I think of the total cost being alone on one side. But you can rewrite things and it still be correct. If I did $4.99 divided by $14.95, would it be correct? Like if I switch to this order, would it be correct? No, order matters in it. Okay, so multiplication, it doesn't, you could do B times $4.99, that's fine. But these two both work, you could leave it like that. Write both if you didn't write that other one. That's a good example. Okay, now the next one. Table 5. Blueberries are $4.99 a pound. Jada buys P pounds of blueberries and pays P dollars. What is an equation that represents that? Okay, class, solid answer? Is it an equation? And would it give us, I don't know, does it accurately represent the situation? Could I switch the variables? No, because it specified what it wants each one to be. And that's a common thing on the test that like, if it tells you to make an equation and it tells you to use certain variables, if you don't use the ones that they pick, they mark it wrong. Granted, I usually look and see if I can do it anyway, but if they want you to use P for pounds, then use the P. If they want you to use C for the total cost, put equals C or something like that. Really similar to the first one. All that's changing is now we're using P instead of B and C instead of $14.95. So really you could alter this around. It could be C divided by 4.99 equals P, and that's still correct. Although I feel like this is what we naturally do. Could I solve and figure out what P is in this one? And why not? Because we don't know the total cost. So in 1A, you could solve for what B is, you have enough information. In 1B, you do not. Okay, so all you can really do is like rewrite it. You can't tell me what P or C is. When you have more than one variable, you can't solve for one of the variables, usually. Okay, table 6. 1C. Blueberries are $P a pound. Lynn buys few pounds of blueberries and pays $P. Table 6, what equation did you write? Okay, class, solid answer. Does it make sense? Yes, I would multiply the cost per pound by how many pounds I bought. Did you say P right here? Yeah. Okay, what should it actually be? A Q. But for all intents and purposes, it was right. We're going based off of this P, but yeah. This would represent it. And this one, it's all variables. You still need to know the relationship between both. What contributes to the total cost? I would still need to multiply my price by how many I'm buying the next. Table 7. Noah earned N dollars over the summer. May earned $275, which is $45 more than Noah did. So table 7, what did you write for that one? Okay, class, does that one make sense? Would it give me what Noah made? So you could box that one up and say that that's right. Can there be other ways that you wrote it? Who thinks they have another way that also is correct? Yeah. 275 minus n equals 45. You guys think that would give me the same thing? How much did Noah make? Okay, I need you to pay attention. You can use the calculator for this part if you want. How much did Noah make if it's 275 minus 45? Okay, 230. If that's the value of n, is 275 minus 230, 45? Yes. So there's other possibilities for 1D. Let's make a list. So that works. They both give me the right answer. Stop looking at each other. What I would have probably thought a lot of people would have is a plus sign in their equation. Because it does say more than. What does more than imply in math? Addition. So anyone have it where it's 45 plus, what would be after? Did I hear 10 or n? So 45 more than whatever Noah made, and then what? Because that's the total that May earned, right? So you could have wrote it like this. And does order matter in addition? So I could also write it as n plus 45 equals 275. Does order matter in subtraction? Yes, like even if you use that 230 that we already said is what Noah made, it wouldn't work if you like switch this order. 45 minus 275 is not a positive 230, okay?
Yeah.
So plug it in, and it makes sense. Questions on that? Okay. Table 8, I think I'm on you for now, for this one. So Noah earned $E over the summer. May earned N dollars, which is $45 more than Noah did. So table 8 would be good for that one.
And 45 is
Okay, M minus 45 equals B. So even if you wrote something different, don't tell me yet, like just think about it. Even if you wrote something different, think about, does this make sense? Is this still true? All right, now you can tell me, is it still true? Yes. All that changed from this one to this one is that now we have a variable for what May earn. So if I highlight it, before we said she earned a certain amount. Now we're just saying she earned that. Everything else is still the same, except also now we're switching out what Noah earned is now a V instead of an N. But that 45 is still there in the same position. Could you write it other ways that are still true? Yes. If you want to know if yours is correct, feel free to call me over, but I think we're good. And so long as you're not mixing up the order completely to something that's give you a wrong answer, I think it would work. So. Yeah. N plus B. I don't think so. Equals a positive 45. Let's see. Okay, so class, this is what we're trying to see. Would this work? Is what May earned plus what Noah earned $45? No, we know that whatever May earned is 45 more than what Noah did, so no, that would. Okay. Would have to be like. I know how to rearrange equations, I haven't taught that to you yet. But it's kind of like solving equations, except for you might not get that M is the answer. If it is the answer. You still would have to undo what's being done. So like, for example, if I wanted to get the M alone, how would I cancel out the 45? So I know like another way I could have written this then would have been where the M is alone. And it equals V plus 45. That's another way you could have written that one that is saying the same thing. But that's like a future lesson. For that right now. Questions? Okay. Last one, table 9. Noah earned W dollars over the summer, May earned X dollars, which is Y dollars more than Noah did. What's an equation that can represent that situation? X minus Y. X minus Y. Okay, class, so let's see if that's right. Y is the more than Noah did. So 45, I guess you could compare it to. That's what it was before. And here's the other ones where we have the 45 alone. So the 275 previously was what May earned. And now what May earned is X. So that looks like it's lining up pretty nicely. Minus whatever Noah earned, which we're saying he earned W instead of N. So yeah, class, is this correct? You could have wrote it this way. What's another way you could have wrote it? If anyone wrote it differently. Wait. All right, you know how I can tell if this is true without like racking my brain too much? See what's alone in this situation, the X. We already verified this is right by like matching it up with what we already know is right. So we know this one for sure is right. If I want the X alone, how would I get rid of this W? Add W. Because right, minus W plus W is just gonna be 0. And whatever you do on one side of the equal sign, so then that would make this cancel, that would get the X alone. And I don't know what Y or W is, so I can't combine them, I just basically write them next to each other. So that does work. What about a situation where the W is alone? That would probably take 2 steps, but I'm sure someone out there has the W alone. Maybe I'll go from this one that's a little easier. If I want the W to be alone, what do I need to do to the Y? And whatever you do on one side. So then that would make this cancel. I would just get W equals. That can also work. But we'll handle those types of equations in another lesson. But that's how, it's the same as when we were solving. Undo what's being done if you want to solve for a certain variable. Questions, comments, concerns? Okay, one more question and it's gonna be your pull down. So it's like your measure to see if you got it. The goal was to see what quantities can vary and which ones cannot. So in summary, if it varies, what do we use to represent it? A variable. If it can vary, we use the variable. If it can't vary, what do we use? A number. Okay, so look for your totals. And determine what can vary, what cannot, so the other side of the thing. Alright, so this is your pull down, I'll still read it to you, because maybe if I read it to you, maybe it'll seem less intimidating, I don't know. But we have a school choir needs to make t-shirts for its 75 members and has set aside some money in their budget to pay for them. The members of the choir decided to order from a printing company that charges $3 per shirt plus a $50 fee for each color to be printed on the shirts. You're gonna make an equation that represents the relationship between the number of t-shirts ordered, the number of colors on the shirts, and the total cost of the order. If you use a variable, make sure you tell me what it represents. And then be able to tell me which quantities can vary, which might be things. I'm gonna give you quite a bit of time before we go over it. I want you all to at least try it. Should you finish early, you can start your practice. Usually the practices aren't very long, so you could like knock it out. But don't do it until you've tried this. This is your self-check during the lesson. So I'll help you with this again in 5 minutes. Try it yourself first. All right, so if you needed to make an equation, what do equations have to have?
Equal sign.
Okay, great. So if you don't have an equal sign, you're technically a little bit off. What is usually alone on one side of an equal sign? Sorry, what was that way? Like a total of something. In this case, it would be a total cost. Did they say that, like, this is how much they're going to spend on shirts? Did they say that anywhere in the problem? Or that, like, they have a budget of blah, blah, blah? So that can vary, can't it?
Yep.
So we should use a variable. What variable do you want to use for total cost? Okay, P. And then it did say to specify what the variables are, so we're saying our total cost is gonna. Now, think about what contributes to that total. Reread the description if you have to. What contributes to the total cost of t-shirts? Dollars per shirt. It's $3 per shirt. That would be something that is fixed, right? That doesn't vary. Do I know how many shirts I need to buy?
Yes,
How many?
75.
For the 75 members. So what math do I need to do to get that total?
3 times 75.
So you can write it like this, you can listen, you could actually do the math and put whatever number that is. But they definitely need to be multiplied. What else contributes to the cost? How many colors are used? Would that add or subtract from the cost? And it does use the word plus, so that does indicate to add a $50 fee for each color that's used. Did it say I'm only gonna use one color? So what needs to go here so that it's not just plus 50? Which one do you wanna use? Up to you. I heard C first, and C for number of colors kind of makes sense.
Yeah.
So some variation of this can still be correct. But you need to be adding in between them. You need to be multiplying the number of colors by 50, because that's how much they're charging. All right, things that vary use variables, things that don't use numbers. I will keep practicing, don't you worry.
Yep. Awesome.
Okay, kind of got squeezed into the end of the lesson, so I just want to make this clear. Things that vary, you use variables for. So like we use variables for the total cost and for the number of colors. And then things that are fixed, we use numbers. So like the $3 per shirt, the 75 members, the $50 per color. Those were things that were not changing in the situation. So that had to be represented with a number. So to summarize the lesson, things that vary, we use variables. Things that are fixed, we use in numbers. Thank you.